Well, we have another CAN bus issue. Y'all love the CAN buses. We got a 2014 Ford F-150 here with a intermittent complaint of electrical issues, and I'm not going to be able to show you the issues. I have seen it, I've duplicated it. It is kind of rare that it happens, but hopefully we'll get lucky real fast. But if I turn the key on and crank it, so everything's working, there's no lights, everything looks correct. We do have a low tire, and of course it's not going to act up right now. Let's turn the air on, see if we can put it under a load to make it act up. I doubt it's going to. What it will do is kind of all the gauges will reset though, like kind of drop to zero and reset. You get a lot of warning lights like the check engine light, stability track or traction light that it has, and then ABS stuff. But it's not going to do it for us. They think it's an intermittent issue, but it's actually all the time. It's broke right now. You just can't tell. So if you check out the screen capture going right here of the picoscope, that's the CAN bus just pinned in down here at the DLC on 6 and 14 and then grounded to the connector. That is not a good CAN bus. If we pause this and pull our cursor down here, you can see that the bias voltage is basically ground. CAN low isn't doing hardly anything. CAN high is able to pull up to about that 3.5 volt range, which is good. So let's zoom in here on a packet so we can see what's kind of going on here. So as you can see here, it is definitely broke right now. So anytime you're dealing with intermittent complaints, it is almost a guarantee for me that I'm pulling the scope out. Just because if it is truly intermittent, I need some way to capture that data of when it happens. Sometimes you can do that with a scan tool. You can catch it in live data, you know, if you're recording or whatever. But the scope tells you what's actually happening to the circuit. Now, I thought this was going to be an intermittent issue and I was going to have to drive it and whatnot to get this thing to act up. But as you can see on the screen capture going, that it's broke. It is clearly broke. Something's wrong here. And to me, just kind of looking at this waveform, I have a suspicion that our CAN low side is pulled to ground and is pulling the bias voltage down. It is able to kind of pull it up just a little bit, but I have a feeling we've got some kind of short to ground. So since I'm suspecting we've got some kind of short to ground, let's just go ahead and disconnect all that. We're just going to check it real fast on the ohm meter, and I've got the key turned off. I've let it sit long enough to go to sleep. We'll switch this over to ohms, and I'm just going to go from pin 16 here to pin 4 or 5, it doesn't really matter. And we do show some resistance to ground, about 20 ohms. So it's not a direct short to ground, at least from my connection here, but that's definitely a path to ground. We should be in the thousands of ohms at least, I would think. I've never seen any too much lower than of like 1500, 2000 ohms. And let's go over to our CAN high side, the blue trace that we were seeing, where we were actually getting a data packet. And you can see we're about 80 ohms. Why are we at 80? Well, that's because we've got 60 ohms of resistance in the CAN line. So if we go from across 6 and 14 here, there we go, 60 ohms. So 60 ohms is the two terminating resistors in parallel to get down to 60 ohms. So that tells me that when I'm on one side of this, this is a little dark in here and I can't hardly see. When I'm on one side of this, the CAN high side, we've got this 80 because we're going from ground through the 260 or the two 120 ohms, which is 60 ohms because of the parallel, through the 20 ohms of resistance back to ground. So hopefully that kind of makes sense. I might draw that out for you. All right, I know my drawing's going to be a little terrible or whatever, but we've got our DLC over here. And we got pins 4 and 5, which are ground terminals. 6 is going to be our high side, and 6 is going to be our high side. 14 is going to be our low side. And I could have that backwards. I can't remember. I never remember which one's high and low, but either way, y'all get the idea. So we've got a few modules here, all kind of just tapped into the circuit, and 2 of them will have some resistors in there. Some 120 ohm resistors that basically tie the high and low side together. These are called terminating resistors, and what they do is they just kind of load this CAN bus circuit to each other to basically take out noise and ringing and things like that. So what happens if we got a short to ground here? Right, this shouldn't be here. This is a short to ground. Whether, I don't know what we're going to find, whether it be wire chafing or corrosion in a plug, I don't know yet. But we're going to check from here and here with our meter, and we're seeing that 80 ohms because one side of the meter is going through both of these resistors. Okay, this is kind of hard to draw and hold the camera at the same time. So our meter is reading through both of these resistors, through this, and coming back to the ground. That's how we got that 80 ohms. Now, if we go to this connector and ground, our meter is reading this direction. So we're not seeing these two resistors, and that got us our 20 ohms. So to make the loop this direction to ground, and then from the ground wherever back to here, is 20 ohms. So hopefully that makes sense, and how you can kind of quickly tell which side of the circuit you need to kind of look at and focus on. So now we need to get a plan of attack. How do we need to go about finding where this is the most efficient way as possible? Well, you're going to have to use a wiring diagram. There's no other way to do it but a wiring diagram. You can guess and guess and guess, and you might get lucky and eventually find it, but wiring diagram is going to be the key. And I generally try to break it down into halves. Try to split the network in half, and then half again, and then half again, until it narrows my focus down into the area that I need to look at, whether it be a section of harness or a module or something like that. So on all data here, I've got the OE wiring diagram pulled up with the data link connector, so 6 and 14, and we know it's our pin 14 side that is shorted to ground, or 20 ohms to ground. So that's going to be the one we're going to focus on. but it's tied in with the high side, so both of these should be going through the same connectors. So it tells us we need to go to 14-2, diagram 14-2, to see where this harness or this circuit continues to go. And Ford loves to do these little splices where instead of like GM, they daisy chain in and out of modules, which I think is a really good way to do it. I also like Chrysler's way of doing it with the star connectors, where everything goes to a star connector and you unplug one at a time. I do like that, but Ford just likes to use these splices, so lots of sections of wire where you can just have a splice go bad. But we're not worried about a splice, because if a splice goes bad, that's going to just cause high resistance to other modules or certain modules. We're looking for a short to ground. So we're thinking rubbed harness or a module that's bad, or connector with, like I said, water intrusion, corrosion, something like that. So on the OE diagram, they are really good about doing connectors. Like right here is a connector, C248, and it's going to be pins 5 and 6 in that connector, and you can see it's going to go on to the next page, which we're a two-wheel drive, so we'll be going to this 14. And there's also another connector over here. The aftermarket redrawns sometimes will show these connectors, sometimes not. They're redrawns. Sometimes people miss things redrawing stuff, so I tend to focus with the OE diagrams, and sometimes I'll use the aftermarkets like y'all have seen to kind of just trace wires faster by highlighting them. But we can see on this section we've got 1, 2, 3, 4, so probably 5 modules, possibly 6. I don't think this thing's going to have a telematics module, because this is a base model work truck. We may not even have the APIM, because like this is just a base model radio. There is sync, so I guess since it's got sync, we will have an APIM. But I don't know about this telematics thing. But let's go on over to our 14-3 and see what else we've got in this network. And we can see we've got a airbag module, powertrain, 2 different powertrains depending on which engine we've got. I'm not sure which one this one would be. Usually, a 6.2. We don't have a 6.2. We got a 3.7. So we've got our powertrain module here. Power steering control module. That says it's 4A37, so we should have that. The ABS module. There's the other end of a airbag module. This one's right here is the passenger airbag sensor, basically. Parking aid module and restraints module right there. So to me, I think that one connector on the page before this one right here, this 248, is probably a good place to split this network apart and check for our resistance to ground again. So I found the connector. It shows by the diagram that it's going to be in behind the kick panel here. And one thing you need to do when you're watching stuff like this is you need to be able to see your meter, have it set up where you can see it. Because I was pulling this panel and I thought I seen this flicker up, but I'm not positive. But it's good to know, be able to keep an eye on that as you're like removing something like this in case that goes away. But we're gonna continue on with unplugging this connector, and if it does, I believe this connector does run to this. I think, I'm not sure. And if that was the issue, if I did actually see that flicker when we unplug this, this is gonna go away. So I'm try to get y'all to where y'all can kind of see as I get this panel off here. I don't think there's any screws in this thing. Nope. There's treasure. You need some fingernail clippers or some other junk. A spoon. Do you need a spoon? Oh man, things you find in vehicles. Quarters. Yeah, gross. Change and all kinds of stuff. But we still got that 20 ohms. Let me see, it shows it should be the bottom connector down under here. This big one right here. And get y'all to where you can see the meter. And I'm just gonna unplug it. If I can see how to. Let me go get my flashlight so I can see. Not really sure how that little thing is locked on there. There it goes. And that went up. So don't know if y'all can see, but we're up to 5,000 ohms now. So wherever this is going is their issue. See, 20 back to 5,000. Let's look at this diagram some more and see what this is going to. So we know our DLC is coming in this direction, and we're going down to this connector, and disconnecting this connector makes this resistance go away, this short to ground. So we know the problem is going to be on this next page, this page 3. So now we need to try to see if we can break this circuit down again, and we've got this connector right here, this C212. That'll be the next good spot. We can split this up again and see, is there an issue with this section of harness or this section of harness. So just in case you didn't know, if you've not seen it on the channel yet, when you're looking at OEM wiring diagrams on all data, particularly Ford's real good about it. When they're in blue like this, they're hyperlinks usually, and you can click them and it'll take you to more information like the connector face, what we're looking for as far as a connector. You can see that's kind of a bigger connector. It's about 4 rows, and then it is also in the left hand kick panel, and it looks like it's kind of up high. It says right here there's a parking aid module connector. There's a ground right here, so we're kind of way up high in this kick panel. So if we come down here, oh, look at this. I think the issue's right here. Y'all seen that, right? That went up to like 100 and something ohms. I think the issue is somewhere right here. I really do. But let's keep following our test plan. So we've got our 20, and under here you can see there's that ground that we've seen, and then right up there is our connector, and then if we had parking aid, right there's the connector for the parking aid. So let's disconnect this and see what happens with this. I don't know how I'm going to do this. I may just have to sit y'all here while I reach up there and disconnect that, if I can, without knocking y'all over anything. Kind of up here in a spot where I can't really see too well. There we go. And 5K. All right. Let me connect that back. 20 and 5. So it kind of appears that our issue should be going out this direction by disconnecting that. Man, I really seen something going on through here. I really thought I seen this change. Let's just do some little quick wiggle test. Yeah, I'm just kind of like wiggling this around. So maybe, I don't know. Maybe it was just coincidence. I think it was just coincidence. So why don't we just follow the data? So now we're going out under the hood. So following on past this C212 connector, we've got a splice, which is going to go up to the analog brake module. And then we do actually have this connector here, C139, which lets data pass through it to this power steering module and then back out, or it would loop if we don't have the power steering module. So it would loop through and then come over here to our powertrain module. So we could find this connector and unplug that one. It is going to be in the right, front right of the engine compartment. Sometimes it takes me a second to see these. Was it C139? I think that was it. Let's go back. Yep, C139. So right front, somewhere right in here, to where it's kind of pointing us to. So let's go out under the hood. We're narrowed down a pretty good bit already, and since I'm kind of narrowed down, this is about the time I'd start to really kind of look at things, especially we're out under the hood now. So I kind of want to just kind of start following the harness a little bit, and we're coming through the firewall right here, and I kind of already don't like this little section right here. It doesn't really look that great. The tape is there, but it's not very good, and the harness is actually sitting against the fender wall right there, so that'd be a good place for wires to chafe. So I don't want to touch it just yet. I don't have my meter set up to where I can see it, but other than that, the harness just kind of goes on around, and I know it's going to come around through here. There's our ABS module, so it's going to drop down to that, and then it's going to follow across here, and our other connector I thought was over here somewhere. I'm not seeing it just yet. May have to look at that diagram a little better, but it shows that it should kind of be in this area somewhere. And I got my meter out here where I can see it, because I want I just want to pull this away from the fender just a little bit and see what happens here. See if this does anything. And it doesn't. So I'm just kind of wiggling this right here, and that is not having any effect on it whatsoever. So I don't think this is going to be my issue. So I still need to find that connector that's over there somewhere. I actually think this is my connector. So I got my meter set up over there. Y'all are not going to be able to see that too well, I'm sure. But I'm going to unplug it. We'll zoom y'all in over there where you can see it. Hopefully. There we go. And my flashlight's dying on me. I'm going to unplug this connector. See what happens. There we go. Okay. So that now proves that our issue is going to be somewhere between this connector where it goes down to the power steering, or back out and around to the power. Golly, I can't talk tonight. The powertrain module. There we go. This whole like video and thing and talking and stuff, it's hard. You should give it a try sometime. All right, so now that we're kind of honed in on this section of harness here, where I'm thinking it's either in this harness that's going down and then looping back to here, or it's going to be from here over to the PCM. I want to move my meter out here, and I'm just going to go straight to battery ground. We're just going to set that in there, and I'm just going to probe this connector and see what our reading is. And on the back side here, you can see we've got a white and then a white and blue right there on the top, and then I don't remember what the colors are coming back. Let me look at a diagram real fast. So on the diagram here, it shows pins 1 and 2 is going down, and that would be kind of what would be going back around to the the powertrain module. Pins 5 and 6 is kind of our lines going down into the power steering module section. So the connector here, I'm thinking we got 3 wires there, 3 on this side. I need to look at the connector view, and I've got that pulled up here too. So pins 1 and 2 should be the white and blue. Okay, and then 3 is empty, and then 4, 5, and 6. 4 has a fused, so one of these is ignition or something, and then 5 and 6 is blue, white and blue, and white and red possibly. So we've got a white and red in the middle there, and then a white and green. So these 2 on this side is the what's coming basically from this direction over. So let's check those. And I'm thinking the low side should be the white and green. White and green. So let's see. And there we go. 20 ohms. So this is the section of harness that is shorted to ground, without a doubt, or the power steering module down there is bad. And then, of course, the diagram shows that the low side's just kind of loop. So is this right? Yeah, 20. So those two, let me go back over here, 1 and 6, so 1 and 6 right here, that is shorted to ground, or down through here. Somewhere in this section of harness, we're shorted to ground. So that's how you kind of just zone in on where the fault is. So now we need to really inspect this harness, maybe do some just very, very little wiggle checks while watching the ohm meter, and see if we can see this resistance change, or we may have to go all the way down to the power steering rack, see what's going on down there. Alright, so I've got the meter set up over here, just pinned in here, and you can see this harness goes around, and we follow it on down. It drops down through there, and I know it's going to be real hard for y'all to kind of follow this on camera, but it's this harness right here, and you can see it kind of just goes all the way down to the power steering module, which is kind of down there. I know it's going to be real hard to see all this, but we're just going to kind of gently wiggle this harness, and I'm watching the meter there, so just waiting for it to see if it does anything. And notice I'm just doing little wiggles. I don't want to do nothing major, just little, because we don't want to move it too much and the issue go away. I want to see it flicker. And so far I'm not having any luck, so it's going to have to go on down. And we're still dead on 20. This is kind of going down through here. Not seeing anything. I may have to crawl under it. Hate crawling under things, but I think I'm gonna have to crawl under it and be able to see and reach things a little better, and hopefully we just see something. Well, you never know what you're gonna find, and it looks like we have found a coolant leak making a mess in my floor. Thanks. So our harness, you see we got these two harnesses right here. Ours is this one right here that's coming down, going up and across, and then it's going to cross to the other side right here. I can't really see that, but I think y'all can. And I've got my meter set up there, which is saying 24 ohms. I don't know if that's from me jacking it up or what, but I'm still just going to go with my wiggle checks, just kind of easily wiggling the harness while I'm watching that. I know y'all can't see that. I'm kind of down here in a dark hole, but I can see it, and so far I've made it to this bend and nothing, not had an issue at all. So let's get on around here to the back side, try not to get coolant dripped all over me. And man, that's bright. Okay. Yeah. So here's our harness coming across here and around back over here to the power steering module, and I think I'm just going to unplug the connector right here and see what happens with the ohm reading up there. Not sure if y'all can see that or not. Right now I'm just wiggling the connector and not seeing any effect. So let's unplug it. Just being real careful, and there we go. It went away. Plug it back up. I don't know if y'all can see that, but unplug. There we go. We got a bad power steering module, it looks like. And somebody has been here and put some goop in this thing. Yeah. The dielectric grease didn't fix it. But yeah, there we go. We need a rack. And if I had to guess, probably this coolant might be leaking into this somehow, because I mean, it's clearly just running across it, and it might be internal that is causing this. That's pretty cool. You guys can still, if I can get you up there, you can see 24 ohms. Unplugged, plugged back up. There we go. So not exactly what I thought was gonna be found. I really thought I'd find a rubbed wire, but nope, we got a bad power steering module on this thing. Okay, so I've got everything plugged up except for the one connector on the power steering module. We're gonna roll the scope here and turn the key on, see what our CAN bus looks like. So there we go, that's much better. Let's turn this air off so we don't drain the battery. So that looks like a good CAN bus. Let's get our voltage scales down to 10. We can even slow our speed or sample down, our time base. And you can see that is a real good CAN bus waveform right there. Nice straight lines. Everything is looking good. Let's go back out to a slower time so y'all can kind of see more on the screen. And I'm gonna go under here and we're gonna plug up the module and see what happens to this, because it's gonna pull it down. And a lot of you are probably wondering how I could even communicate at all like that, and I'll talk about that in just a second. So let's get down under here, and we've got the connector undone right here. So we'll plug this back in. If I can feel it with my fingers. There we go. Is there a scope pattern on the trash now? It's gotta be. Yeah, there's our trash scope pattern. Now, how could the car even talk and communicate like this? Well, it's all about how CAN bus operates. It's looking at the differential between CAN high and low. So if we actually just go in here and let's just add a math channel. We're going to do, I think it's A minus B. I think we'll move this down out of the way so we can actually see it. So if we zoom in here, this is probably going to look like a fairly decent waveform. Get rid of this. If I could get things to work. Math channels. What? Has Pico crashed on me here? I think Pico crashed on me. Alright, I got Pico scope fired back up. I don't know why sometimes it does that. This is the first time it's actually happened on this laptop. But we can see we're doing our math channel of A minus B, and if we pause this, we'll zoom in down here on our packet. This is not going to be that bad of a packet. That's what the module's seeing. It sees the voltage difference of about 2.75 volts. That's about a normal CAN packet. So this is what the module is seeing. All right, so I'll take a little screenshot of this. So this is what the modules are seeing right now. Truck's running, and everything. You see, we do got a little traction control light. God, I just can't think and talk tonight for some reason. But let's unplug the module, and we'll see what actually happens to our math channel right here. You can see there is some wonkiness to it. Let's close that out. Let's bring our time base down a little bit. There we go. That's pretty good. So you can see though, what the modules can see looks like a pretty decent CAN bus. So let's get under here. I'll unplug it. We'll see what happens with our math channel. It's not going to change that much. At least I don't think. I could be completely wrong. So let's get under here, and I don't know if y'all guys can see or not, but it's unplugged. Now let's go see what our math channel looks like. Y'all already see it because you're seeing the overlay. And there we go. Clean CAN bus. But our math channel, yeah, it's cleaner, but the math channel is basically the same. About 2.5 volts. And that's why the truck can crank and run. And then when it was having this intermittent issue, it was just this math channel basically getting too dirty, too out of whack, just not clean, crisp lines. And that's really all there is to it. I mean, pretty unique failure that presented as an intermittent issue that was actually there all the time. That's a cool case study. So that's a good waveform right there. I'll screenshot this to have for records and things like that. And I'm gonna tell them they gotta get a power steering module or a rack. They're gonna be thrilled about that, I'm sure. So what do you guys think about this case study? Thumbs up, thumbs down? Do you like it? No? Yeah, I mean, the last video with CAN Bus, y'all said y'all like CAN Bus videos still, so here we go. And this was a pretty unique failure. I have to admit, this is a real unique failure. But that's basically my process of working through all CAN Bus faults. You know, determine what's happening to the bus, and then break the network down until I narrow in on the failure. So that's it. Thanks for watching, everybody. If you enjoyed it, hit the like button, hit the subscribe button if you're not already subscribed, and we'll see you guys later.